I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Software-Defined WAN, Security Implications and Design Solutions. My name is Steve Warzala. I'm the CSIAC Outreach Manager. A few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. Time permitting, we will answer your questions at the end of the session. Today's briefing slides will be posted on our website within a few days. I'd like to briefly mention that our webinar for next month will be examining blockchain technology, and that presentation will be conducted by Professor Tang from Syracuse University, and we'll be doing that on Tuesday, December 19th. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. It's my pleasure to introduce our presenter for today's webinar, Mr. Ken Kaminsky from Cisco Systems. Ken is the Network Security Technical Solutions Architect for the Global Enterprise segment. In this capacity, he covers a wide breadth of areas, including identity management systems, network segmentation, network security, security in data centers, BYOD and mobile devices, as well as wireless, network switching, and routing products and technologies for large enterprise and global accounts. Ken has been a member of the Security Field Advisory Board at Cisco that drives the training and programs for Cisco security systems engineers and provides customer feature requirements to Cisco engineering. We'll now turn the presentation over to Mr. Kaminsky. Good afternoon, Ken. The floor is yours.
Thank you, Steve. Appreciate that. So what I'm going to chat about this morning is software-defined WAN, which is kind of really a major technology that we've been seeing has really been transforming traditional wide area networks. There really hasn't been any change in those topologies really for the last 20 years or so, and SD-WAN is really the first kind of major shift in the way that wide area networks are built. So what I'm going to chat about a little bit first about what it is, so folks understand kind of the main components of it. And I'm going to talk about the two main security models about how it's implemented. And they're quite different. One is just using traditional tunnel transport and, centralizing the security assets at the head-end location like we've traditionally done with most WANs. And then I'll chat about direct internet access at those remote branches and what that actually means and the implications there. So we've seen a huge uptake in this technology with SD-WAN. Gartner had predicted a couple of years ago that, about 30% of the enterprises will deploy this to all their branches by 2019. I would say that's accurate. Somewhere around about a quarter of the enterprises that we're dealing with have active SD-WAN projects, in place, or they've already put the technology in place. So it's something that's really beginning to roll out there. In the enterprise WAN space, there's a couple of trends that we've been seeing. So first of all, the need for bandwidth in those locations has been growing now for quite some time. And that's due to, things like applications being deployed out in the cloud, things like Office 365, things like Cisco WebEx, Salesforce.com, accessing things in Amazon Web Services. All these things are really driven a need for users in those remote branches to have more access to that. Along with, mobility devices increasing and just the prevalence, in particular, of video being on those devices and just the bandwidth requirements that those applications really dictate. So we see at the same time, this need for bandwidth in the branch is increasing, while at the same time, IT budgets have been flat or declining. And the WAN budget, the transport or bandwidth costs are really the majority of the costs for that particular budget. So it's a bit of a, a catch-22 there. But at the same time, we've seen a real movement towards lower cost transport, in particular over the internet and other type of areas like LTE type connectivity there. And what's happened over the years is the internet has become more and more viable as a transport mechanism. So most enterprises built MPLS networks, in order to be able to control things like availability. So they wanted like 99.999% availability, on those networks for their wide area transport. But as the years went on, the internet kind of moved from being just a backup type capability to a major viable kind of transport mechanism. And you can see the movement of reliability really over the years with this graph here. So in the vertical axis there, you've got, the cost of internet pricing over time, with being the vertical axis. And you go back a number of years, the internet really wasn't reliable. But as time has gone on, you see this vector has moved up, as the years moved on, into the 98th percentile there, and that's always increasing. So the reliability of these internet connections has gotten better and cheaper over the years. And we look at, somewhere around half of all the organizations out there looking to transition those more expensive WAN connections over to the internet here. And that's been a major portion or a major, component of SD-WAN becoming viable. So what SD-WAN is made up of, it's really moving, from this MPLS only type system into, most of them will do MPLS along with internet as a major access or a major transport component there. And I'll show you some of the different, layouts of how customers are actually deploying this. But all these SD-WAN systems are really made up of the same type of components. So all of them, first of all, have a control plane or a software-defined controller that's managing all these devices that are out there. These could be physical routers that are out there that have these capabilities built into it, or they could even be virtual routers. So this SD-WAN controller is doing all the automation for the configuration and also all the figuring out from a dynamic standpoint of how connections are actually going to route and over which major transport they'll actually go out and route over. So that controller is a big part of it. That's really the brains of the operation from automation and routing from that standpoint. And then going from left to right here, all of the vendors that are out there have, most of these components that make up their solution. First of all, it's transport independent. And what I mean by that is we're running one overlay tunnel architecture over whatever transport is going out there. This is generally almost always IPsec tunnels, and we're going to run those over, let's say, an existing MPLS network and then also out over those internet connections so that the network just sees one network to route over regardless of what your underlying transport is. That could be MPLS, that could be 3G, 4G LTE, or it could be a classic internet connection. It's all one tunnel transport mechanism that's running over both of them so that the controller can just look over one architecture or one infrastructure and go ahead and route connections accordingly. The second major component is intelligent path control that makes up these SD-WAN solutions. And what I mean by that is we're dynamically routing connections based on application here. Now, this is very different from the way traditional IP routing works. So with traditional IP routing, we're just taking a connection and we're routing it by its IP address going a certain direction. Here, we're actually introducing a lot of intelligence into this, and we're literally looking at these connections by application type. And we're saying, all right, that's a voice connection. We're going to route that over MPLS. Or, hey, that's a video connection. Let's route that over MPLS. This is an email connection that's going out. Let's route that directly out over the internet connection. So literally, application by application, even getting down to the level of, is that Salesforce.com? Is that Office 365? Is that, Cisco WebEx? This is the path we're actually going to route those connections out. So it's a very intelligent mechanism based on applications that's out there. Also, all the architectures that we're using are running and active at any one time here. So we're going to be using, things like load balancing, where we can load balance connections, over certain transports and send them out that way. So very intelligent, just in terms of how this is done, in terms of the intelligent path control. And again, all of that's, from the software-defined controller. We've got application optimization, this third major area here. And this is mainly, having this visibility into the applications with also the ability to do performance monitoring over these paths. So there's always probes that's going out over these different transports that are measuring, the actual, how well these connections are actually doing and how well they can go ahead and transport things like voice and video. So all these probes are always monitoring, things like overall latency, overall jitter, with inter-packet delay, and all these things really matter if you're sending things like voice and video out, in particular over the internet connection. So if any of these transports begin to degrade, what we can do with software-defined WAN is we can automatically reroute those on degradation over the better path. So all of these probes are always running, and whichever is the best path that's out there will be the ones that will route this on an application-by-application basis. Also integrate application acceleration and bandwidth optimization, or traditional WAS services, and that's integrated into those products. Riverbed and Cisco, for instance, do this. And then you've got secure connectivity. This is where a lot of the vendors that are out there will differ. A lot of them have integrated security components, such as strong encryption, the VPN technologies, integrated firewalls, integrated integration with various, cloud web security proxy vendors and stuff that are out there. And I'll go ahead and I'll show you what those actually look like. What those different components actually look like. Now, here's the difference between a traditional WAN over on the left and an SD WAN over on the right, just so you kind of get these concepts down a little bit more. A traditional wide area network, might be running traditional MPLS or even multiple MPLS vendors here in a lot of environments there. Also some of them will be running, VPN over the internet. A lot of times is just backup technology. So if I've got two networks here in a traditional wide area network, one going MPLS, one going to the internet, I'm actually running, different encryption technologies over that if I am encrypting it over MPLS, and I'm running a whole different, encryption scenario over on the internet side of the house, and this is normally an active standby. So I've got my major path is going out the MPLS network, and my VPN is only there upon, failure. So if my MPLS network goes down, my router will go ahead and route, that traffic out the VPN. So often this is just an active standby. And we also have two different routing domains that are running here. So I'll have one routing protocol running over my MPLS network. I'll have a completely different routing protocol that's running out on my backup VPN links here. Now compare this to SD-WAN. This is an active scenario. So my VPN that I'm running over both of these architectures is I'm running one VPN over both of them. So my router here sees just one integrated network, and I can route traffic, out over those much easier because it's all one VPN tunneled network that I'm seeing. It's just one goes out, in my example here over the MPLS. The other one goes out here in my example over the VPN. So I've got one overlay, one VPN overlay infrastructure. I've got active infrastructures. This is not an active standby. Both of these are active at all one time, and I'm only running one routing protocol over both infrastructures. So much more efficient. I can punch a lot more data through an SD-WAN environment than I can over a traditional WAN environment. Okay? And usually the way this is deployed is one of these three models, and this is what we're seeing out there, in the real world. So the customers that want to stay with MPLS only, a lot of times they have two, maybe three. I've seen, even more MPLS providers depending, on the customer, and they'll use this technology to combine both of those carrier networks into one SD-WAN. And route, traffic over both of them simultaneously, running one overlay VPN and one routing protocol. The most common one is the middle one that I'm seeing, especially with large customers, and that's called a hybrid model. And what they're doing here is they're running an MPLS network, and then they're running an internet connection also. So we're combining those two together into one architecture and then intelligently balancing applications over those. If you're really going for the very low-cost solution, because MPLS networks tend to be, a little bit more costly, then we're seeing some customers, just for cost reasons, saying, I'm going to do dual internet. So they'll go with two internet service providers, and they'll run two internet connections out there and use SD-WAN to make them look like one logical network. So generally this is what we're seeing. It's either dual MPLS, it's hybrid, or it's dual internet. And then the way that this is leveraging the internet, is important, especially from a security standpoint. So if all we're doing is doing secure transport, this is this top one here. This is no different than, how we've been running VPN networks forever and a day. And, the security implications of this in this centralized model are not that severe at all, and I'll kind of show you what those are. The real security implications come in is when I'm saying, instead of using this internet connection just as a VPN connection, heading up to my head end, when I'm going to allow direct internet access for these users out in the branch directly to access the internet. That's called direct internet access, or DIA is kind of the terminology that's used there for that. The security implications then are fairly severe, and you have to have a lot more controls in that branch whenever you're doing that. And again, I'll go ahead and I'll show you what those look like. This SD-WAN market has been increasing, over time. These are just some Del Oro, numbers here showing you control plane software numbers along with routers, either physical or routers can be virtual there also. And this market continues to ramp up, and we're seeing this fairly rapid explosion as we're moving, over time to a $1 billion market here. All the vendors, that we're seeing out there are listed over there on the right-hand part of the slide. So let's break these down. Let's take a look, first of all, at the tunnel transport, or the centralized security model. So in this model here, we're really doing this over on the left. All we're using the internet for is for VPN tunnel transport. We're not allowing direct internet access for the users out in the branch, and this is a more traditional security model whenever we're doing this. And this, by the way, by far is the most popular way that I'm seeing customers actually deploy this in particular initially. So, and when we're doing this, this is really no different from the models that we've been using for things like IPsec, tunnel, IPsec VPN access. We've been doing these types of architectures for a long, long time now. And when we're doing this, we're just looking at traditional things like, IPsec overlays. We want to be able to be using strong cryptography, modern IKE, keying protocols, in particular IKE v2, and then modern encryption protocols that we're using on these tunnels here. The only thing that's actually allowed over those router interfaces are just this IPsec traffic. That's really the only stuff we're doing. And this tends to be, really no different, from the wide area network architectures that we've been deploying for quite some time. You want to be doing very strong device authentication here, in particular using a PKI with certificates to authenticate, all of these routers that are out there, whether they're physical or whether they're virtual. And we can use traditional segmentation methodologies like routing VRFs in order to go ahead and isolate even different routing overlays over there if we're segmenting, different portions of that remote site traffic. So we might have a different routed portion of the network for IoT devices that are out there. All the production users may be on another VRF, and you can really segment those, over the wide area network using that technology. And when we're doing this, what we're doing here can be protected using traditional ACLs. Again, we've been doing this type of an architecture and layout for a long time now. Here's just an example of that routed interface and the stuff that you might allow in over it. So what you're looking at there are things like, the ISACAMP, which is the IKE keying protocols there, the actual IPsec tunnel traffic there, which is running over ESP. We want to allow boot PC because we got to allow DHCP. That router generally is connecting out to a service provider. A lot of times that's not a static IP address, it's DHCP assigned, so we can go ahead and let that in. And then maybe we want to let a couple of ICMP protocols or packets there, hit that interface. Different mechanisms like echo reply, depending on what we want to allow from a troubleshooting standpoint. But only these things would be allowed to hit that interface, and only those protocols would be allowed to actually move through it. We don't really necessarily need to have a full firewall out here in this particular example. Some customers are a little bit more security conscious and they want that. And, in a lot of the SD-WAN vendors, they have an integrated firewall that's part of the router, and you could actually implement those with a full stateful firewall there if you wanted to. But, the ACLs are generally sufficient here. Okay, and then when we're doing this, we want to be thinking about other things like, we're connecting and we're shipping these devices out, and these devices are connecting, over the internet. So we want to think about, things like, can I trust this platform? How do I know it's come from the manufacturer that I bought it from? How do I know that I can trust this platform? Comes from the reseller, that I've bought that from. And then even do I trust, the provider's WAN? So is this MPLS? Is this, what is the actual service provider that I'm actually moving over, and do I trust them going over that? And vendors have implemented different mechanisms to be able to actually, make sure that we can answer these questions. And we can start here at the actual, hardware itself. How do I verify, that the hardware is from the vendor that I bought it from, that all the software components are actually, belong to the vendor, and they're part of what should be loaded up on there. And the whole system here really revolves around signing the software, and that's anchored by a chip that's actually implemented by the vendors on the actual platforms. These have been called anti-counterfeiting chips, anti-tampering chips. A trust anchor module, is another term, that Cisco uses to talk about this. The Trusted Computing Group uses a term called Trusted Platform Module, or TPM, to actually talk about this concept. But the big thing to understand here with it is that this is an actual chip that's going to anchor the identity for the actual device, and is going to be used for the signing process for all of the software that's going to load over there. But it's anchored right here on this particular chip. So this chip has immutable identity for the device. There's actually a standard that's out there called IEEE 802.1AR. And this implements a certificate infrastructure. So the vendor root manufacturing CA would sign this, and then assign a certificate that lives within this hardware that operates on this process called a SUDI. This is this term that's right there, which stands for Secure Unique Identifier. And the way most vendors do it is they'll go ahead and implement the actual product ID of the router, that's being shipped, along with the router serial number, and they embed it right in that X509 certificate. And this is used as the beginning of the trust chain here. This chip can also be used for the secure storage of credentials that are out there. So all of the keys can be stored here on this chip. All the entropy for random number generator, a lot of these are built into the next generation of these chips, so that function there to do real, genuine random number generation, which is important to any cryptographic solution, is embedded in the second generation of these chips that you'll see from vendors that are out there. So this is really the anchor, and then what happens is that's used to basically figure out and guarantee that every piece of code that's going to then boot up on this box is going to be verified. So as the box boots, it will go ahead and grab this information, from the chip, and that begins the identity chain here. That will be used then to go ahead and take a look at, what's next there in that boot chain, which would be, the secure micro loader. So we're loading up that. That will then go ahead and load up the BIOS. Now, each one of these components is then individually signed by the vendor and checked in sequence. So it's looking secure micro loader, then it's looking at the BIOS, and then it's looking at the actual operating system that's going to run, and it will look at any modules that are actually running and booting up on the platform at the same time. So this is really how, vendors are implementing, things to make sure that when a piece of gear ships to your site and you connect it up, that this actually did belong to the vendor and it hasn't been tampered with in the entire process there. And all the vendors maintain this chain of integrity so that if you query them about a certain, device and a certain, load of software, they have all the records to be able to say, yes, this is where I got, this was manufactured, here at this place. this was shipped to this particular reseller, and here's the actual chain that it actually flowed in. Right? And then once it's there, you actually connect this thing up to the network, and this is all software defined, so everything's automated from these controllers. So the device would boot up, it would do its hardware and software validation there, and then it's going to do a secure bootstrap. It's going to talk to that controller, and then that controller is going to automatically download its configuration and, you know, all the trust and keys and everything else that are associated with the, you know, the PKI that it's running there on its side of the house also. So it gets all its configuration there automatically. It's going to exchange all the keys that's needed for that VPN IPsec overlay there. And then this same mechanism is going to be used for automatic session key refresh and rollover. So this happens on an automated basis, so the keys are always changed, you know, on some regular interval. All the trust revocation for all of those certificates is also included, you know, within that SDN controller. So if some site is compromised, that certificate, you know, for that specific router can then be revoked and controlled through this particular mechanism here. Again, all of this is done from the software-defined WAN controller. And this is all meant to be an automated process in order to remove a lot of the operational or the OpEx, you know, that's associated with WAN devices. The idea here is to make this as automated as possible. All right? You know, and then when we're looking at this, you know, everyone always wants to look at, you know, the various certifications that are out there, you know, across the different, you know, different vendors and how the vendors certify. You know, the big ones that are out there are things like common criteria. You know, that's for all the security and the security-enabled products that are out there. These define these things called protection profiles that basically replace the older way of doing things, that will define, for instance, you know, what a firewall should do. And you can kind of look at this and see the vendor's compliance, you know, to common criteria. On the cryptographic side, you know, in particular in the federal space, but I see this also in a lot of major industry verticals, people want the latest, you know, FIPS validated 140-2, in particular, you know, how they deploy their crypto systems. You know, the algorithms, the hashes, all the other components to use within the crypto system. They want everything kind of certified to this standard. And then also, you know, folks like the NSA and, you know, other folks like the Australian Signals Department, you know, they have a lot of very, you know, valuable kind of recommendations and documents, you know, that they'll go ahead and put out. You know, with different recommendations and things like this for kind of different security certification standards and whatnot. So these are good things, you know, to take a look at. Whichever vendor that you're purchasing from, you know, you take a look along those lines there. When you're looking at strong encryption, you know, and this in particular is along the lines of FIPS 140-2. In particular, the conversation is along the lines of we want the Suite B support, which is really an entire crypto suite upgrade, not just, you know, am I moving from triple DES to AES from a confidentiality standpoint, but you actually have to look at the entire crypto suite and make sure that all of the components that make up that crypto suite are, you know, up to speed and will last into the future. Because folks are deploying platforms out here that they want to be able to run out there for many years, and you want to be able to make sure that these are, you know, up to speed in terms of, you know, where the latest attacks are coming from, and, you know, how long in particular in the future these will last until. And, you know, a date of like 2030 is kind of a date that a lot of folks will look for. And they look for, you know, what's been broken, both from a practical standpoint with real-world exploits and theoretical problems. You know, are they theoretically broken just in terms of, that crypto mechanism that's being used there. So the recommendation here is to move towards a strong Suite B, support with all of these different components. So that's moving, in particular to AES. AES 128 is kind of being the one that a lot of the enterprises out, that I work with will standardize on. Because in terms of, computing advances and where, folks can break certain cryptographic key strengths, folks, kind of settle on, kind of a nation state could break about, 80 plus bits today. By 2030, where computing's going to, that will be around 100 bits, so you want at least to be at, around 128 bits there in terms of the key strength that's there on that. A lot of other recommendations go along the lines of using AEAD, which is Authenticated Encryption and Associated Data, which is part of the AES 128 GCM component there. That combines the authentication of the packet, so it's authenticating that the packet has not been, adjusted or shifted in transport, along with the confidentiality or the encryption of the data itself. So instead of having those as two functions, AED combines them into one, and that runs very well on modern hardware in particular, so it's a good one to actually go ahead and target. On the key sizes, there's been a movement from RSA, Diffie-Hellman, over to the elliptic curve cryptography, or ECC, that's been going on for quite some time. ECC is very scalable when you get up, in particular, into key sizes that get up into the large numbers. So on the hardware in particular, it runs a lot more scalable there. There has been risk for RSA keys that are out there. So the folks that are kind of in this business are recommending definitely you got to be off the RSA 1024. You should at least be at 2048, and the recommendation is even moving to 3072 from that key bit size. On the hashes, the collision attacks that are out there have been noted. Collision attacks being when I can have two blobs of data that comes up with the same hash. It's something you definitely don't want, because I don't want, one blob of data to say transfer $1, from the bank account to be the same as transfer $1 million. So these collision attacks are something to look at, and the recommendation is to make sure you're not on the older SHA-1 MD5 and to move into SHA-256. The entropy is important here too. Random numbers are very important in these crypto systems, so you want to be able to make sure that whatever entropy sources we're using are up to speed. And then there's a lot of the old protocols that put this stuff together, things like TLS version 1, the original IKE v1 version that have known flaws within them. So you want to be running more modern versions of both TLS, and in particular you want to be on IKE version 2. So when we're looking at a crypto suite, these are kind of the big picture things that we're looking at, and we want to be able to have a system there that I can leave out there for some time and will be, safe, with general consensus, for some time in the future. Okay, that was the centralized model, and those are the general ideas that come into that. What I'm going to talk about now is the implications of using a direct internet access and what that means. And again, that's in our SD-WAN model. That's when I've got this internet pipe, and I'm using it not only for a VPN tunnel connection, to my head-end routers that are out there, but I'm now allowing my users that are out there in all these branch locations to actually have direct internet access, for all of their applications. And this is a lot different than under the first model, where when I have a user that's out there that needs to get access to the internet, Under the centralized model, they flow over the tunnel and they hit all of those centralized assets that are up there, things like my secure web proxies, my next-gen firewalls, my next-gen intrusion prevention systems. All of those security mechanisms can be concentrated at that central point, and I can protect that internet traffic that way. This is very different now. Now I'm allowing them to go out the branch, and there are implications here. So now I have to, in particular, at the very least, have a full firewall that's out there, generally a next-gen firewall with all of those features and functionality that I want from that. And I also need to have secure web proxy access at the very least out here. So instead of, using some centralized, vendor like a Cisco or a Blue Coat product or something like that, I've got to have that functionality there, at each of those branch locations. And most folks here will use a cloud web proxy in order to do this because it's much more cost effective rather than putting another piece of software or a piece of hardware that's out there. So at the very least, we're looking at a firewall and a cloud proxy, and depending on our use case, we'll be looking at more controls that are out there. And I'll show you what those are. Now, whenever we're doing this, you have this dichotomy here. Your network guys and your CEO, they love this stuff, because this allows them to send all that Office 365, Salesforce.com, all those web applications. I can just send them out there instead of trying to pack those over a WAN pipe. So in general, they love it. And the folks that hate it are the security folks, the CISO, the CSO, and the security team, because they are horrified because this is now an internet access point, and just the scope of the environment that I have to deploy all my security controls to has now increased to encompass all of those branches that are out there. So you generally see a push to do it from the network side and a horrified push not to do this thing from the actual security side in an organization. And the way that this breaks down, this is dependent on the use case. Now, some use cases you can do this with, other ones are a little bit more dangerous to do this with. And I like to break this down with these 4 use cases. So direct internet access falls in under one of these 4 in general. And these go from pretty low risk over on the left to very high risk moving over to the right. So let me define these. So compliance is actually a centralized model, but for compliance reasons, you have to go ahead and deploy different security mechanisms out there. So this is still a centralized model. I'm not allowing this direct internet access for the users, but because of what my security demands are in the enterprise, I still have to put things like an IPS out there. I still have to put things like a firewall and some of these other controls. This is fairly low risk, and you can generally get away with some fairly low-level controls that are out there. Another one moving over to the right is one that also can be done with some fairly low-level risk. And this is just to allow guest access out in my branch location. So the only thing I'm going to connect is a network segment that is just doing my guests, and I'm going to completely isolate that from my internal network segments there that are using my traditional SD-WAN VPN components. That also has, a certain level of risk. That can be done also, fairly lightly. It's where you're getting into these other ones here where now I'm allowing my users direct access out there into the internet that this becomes problematic. And we generally break these down by folks that want to do direct cloud access or direct internet access. And the difference between these is with direct cloud access, The only thing I'm allowing those users to access are my acceptable cloud applications. So the only connections that get routed out there, for instance, are just Office 365, they're just Salesforce.com, they're just Cisco WebEx, etc. Versus direct internet access, it's everything. Not just a certain subset of applications, but I'm routing everything. If the user needs access going out, then everything gets routed out that direct connection. And the risk on that, obviously, is a lot higher. So just a little bit about, each one of these use cases here. So the guest one, you can generally do this, fairly easily. You're isolating a certain segment out in that branch and completely isolating those guest devices. So this is usually a wireless connection, frankly. There's a wireless SSID that's up there. It connects into a VLAN that connects into generally a separate VRF that has its own little routing domain in a lot of cases there, and that is completely separated from the internal traffic and the internal VLANs and the internal routing domains that's there. And the controls usually that we'll put in place here is we'll have a firewall, that will go ahead and firewall this stuff, so that we're talking about a stateful firewall as being part of this. We're usually using some cloud web security provider to do content filtering and policy enforcement for those users. And a lot of times there's some basic IPS that's out there, maybe just some snort-based IPS to keep an eye on, the segment that's actually going on there, to have a little bit more kind of eyes on that segment that's there. We see this in a lot of retail stores, hospitals, pharmacies, financial branches, schools, universities, etc. This is a pretty common use case. This one here is direct cloud access, and this has some major, cautions here that I'll talk about. So again, what we're doing here is we're only allowing a specific subset of applications to go out this particular pipe that's here. All right? So it's only allowing Office 365. It's only allowing, Cisco WebEx, Salesforce.com, etc. Everything else, other than those allowed applications, has to route over the SD-WAN pipe connections going up to the head end in order to access the internet from that. So this is a subset. And frankly, this is the one that I get asked the most about, because this is the one usually folks want to do. Now with this one, obviously we need a lot more controls that are out here. So we're going to need a full Nextgen firewall kind of application here, a full Nextgen IPS application, that's out here, along with, cloud-based, web services and whatnot, in order to protect all that user traffic. Now that has real implications, because I've got to deploy, all of those tools, and I've got to manage all those tools to those different locations. And there are real management concerns when doing that, in particular with a Nextgen IPS. I've got to be able to manage all of those, because those tend to generate a heck of a lot of management traffic. So there's only a certain number of those remote branches that I can manage, from any management console. Same thing with a Nextgen firewall, but the Nextgen IPS tends to be a lot heavier, on the management side of the equation. So we're looking at deploying all of this stuff, out there, and what those implications are when we want to do that from an operational standpoint. Now, I want to call out to you, this is a work in progress here, because the reality here of whether this will work with the vendor you're asking depends on how they're doing this. And this is really spotty. Some vendors do this, some vendors don't. Everyone's moving towards it because everyone wants to do it. And I'll divide the problems up into kind of three major areas here as to whether this will actually work in the real world or not. First problem I have is I have applications like Office 365. Office 365 has 160 plus IP addresses that are out there, and those often change every month. And the way that most routing systems work, in order to route traffic a certain way, is I have to know the IP address in order to route that traffic out. So if I have a vendor that's offering this service and their IP addresses don't change that often, I can generally route them out to this internet connection pretty easily with some mechanism that I have built into the SD-WAN router. But if I'm doing this often, I have a real operational problem on my hands, because I've got to always be entering those changes, whenever they happen, in order to make this service work in the real world. And again, that can be problematic. So that's problem number one. Problem number two is the way these cloud web proxies operate. Is they often operate based on what are called the whitelisting model. And these IP addresses here, the way that it often works with these is you're listing out the IP addresses of the things, that are going to route up and stay within the corporate network. And then anything that's not on that in a lot of these implementations will route directly out to the internet. And a lot of times, the ones that are going to route directly out to the internet, there's a certain number of those that you can have under these models also. So, the model itself may get in the way, and then the number of these that you can have will get in the way also. And this is also, still built along the idea of defining the IP address itself. So the cloud web proxy vendor's model, you got to take a look at that and see, okay, in that model, how do I do this? Do I have enough of them? And can I really do this and define this, what I'm looking for with this list of applications that I want to route out there? Now, the third problem is from the perspective of the SD-WAN vendor themselves. And that's how on earth do I need to route this? Because in order to make this system really work, I really have to route by domain. So I need to be able to route on the domain that I'm going to. So I'm routing out to Microsoft Office 365. I want to route based on that. Now that's a problem because all routing protocols route based on the IP address. They do not route based on the domain. So the SD-WAN vendor has to have a mechanism here where they can actually look at all the DNS queries that are going out there, kind of tap into that, and then figure out how to route those based on the actual domain itself and not the IP address, because that will solve all the operational problems if I can do that. One of the ways that's been kind of bandied about and some folks are implementing this thing called DNS as an authoritative service, or DNS-AS. And what we do is we add a couple more data points into the DNS record. So, in one implementation here, you can add in the application ID, that's being used by the vendor here in order to route the application. So, Salesforce.com gets one, Office 365 gets one, so on down the line. Now I could match an IP address to a domain name to an application, and then I can add a policy into that DNS record also, like route directly to the internet. And if I've implemented this system as the SD-WAN vendor, now every time a connection goes out, I can look at this and I've got more data points in my DNS system. This is fully standards-based, and it is a pretty decent way to go ahead and solve this overall problem. So you add these two pieces in here, and then you can route it out. And then you can link it to the way that the SD-WAN controller is routing traffic. So now that's tied to the application. Now that's tied to this path. That's great. Or you could link it to traditional router mechanisms like policy-based routing, or PBR, And if I've done that, I can solve the problem this way also. So the biggest call out, again, that I want to leave you with on this slide is, this is definitely a work in progress. Some vendors do it, some don't. And it's something you want to ask and kind of chat about if this is the overall, solution that you're looking to do with your direct internet access. Just pointing it only at specific authorized cloud vendors. The last one is the most risky. This is direct internet access. This is everything goes out the pipe. So every time an employee wants to go out from my branch location, he goes directly out to the internet. Most efficient in terms of WAN bandwidth, but also, the most horrifying from the security standpoint. So we've got to look at having all the different controls here, in the branch, from the Nextgen Firewall to the Nextgen IPS to, the cloud security vendors and the services that are out there, and all the centralized monitoring that I've got, along with these different controls. So this tends to be, operationally, from the security standpoint, a very, very heavy and expensive use case to go ahead and implement. Okay, so that's the one with the most warning. When we're looking at some of these use cases, in the compliance model, or if I'm just doing guest access out there, a lot of times I can get by with just, putting some of the traditional open source IPS, stuff that's out there and integrate that into my branch environment. And that'll work, for those particular use cases. As we're getting into, allowing direct internet access, for those specific cloud applications or the wide open one, now we're looking at a full-blown Nextgen IPS, with all of the Nextgen IPS functionality that we'll want to have in that particular, that security control that we're going to put out there in the branches. And a Nextgen IPS, has a lot more than just the signatures that are out there. These encompass, a lot more management functionality, looking at the application itself and having control there, gathering context about the user, the device that they're connected to, from the operating system that's running, from the application that's running on it. They have things like impact assessment, that's part of these products that basically says, hey, that's a Linux attack, but yet that's a Windows machine. This isn't much of an impact on this. So, I can kind of ratchet down the response based on that. There's a lot of automated tuning. These signatures tend to be, a lot in number and, very varied on how they tune to different environments. So these products with Nextgen IPSs tend to have a lot of that automated tuning capabilities built into them. And then the user identity information is generally built into these also. This is also, I kind of wanted to throw this in here. There is a movement in general with the security vendors that are providing cloud services. You go back a number of years and they were, for the most part, what were called secure web gateways. And these were providing that secure web proxy functionality primarily for ports 8 and 443, and then encrypted traffic like with HTTPS. It was only along these ports, and they were concentrated on those services coming from, a lot of times from branch locations, or it could even be from large-scale enterprise sites. So instead of deploying vendor solutions, you go all with a cloud vendor and you do this whole thing from the cloud. It was geared around web traffic in particular, giving, application visibility and control, web content filtering, etc. There's been a movement, as vendors kind of move into what's called secure internet gateway vendors, which, instead of just the port 80 and 443, they operate on all protocols and they integrate more with the cloud access security broker vendors that are doing all the kind of security controls with the various applications that are running up there in the cloud. They'll operate more on a broader basis, but you'll see a difference between them. You know, your SIG vendors don't have, you know, a lot of the data loss prevention functionality necessarily built into them, or some of the bandwidth controls, you know, built into them. They tend to be missing this, whereas the secure web gateways, you know, don't have some of these other functions. But it's just kind of a general direction, you know, that the actual kind of cloud security market is moving in. And this is just kind of illustrating some of the other differences that you see between them. You know, one being focused more on web, more on AV controls here, this more on, you know, all the other protocols that are out there, and a little bit higher layer of controls to be able to look at files and to be able to retrospectively look at that file later on, you know, whether the malware, it wasn't known at the time, but then later on, you know, it becomes known, and to be able to retrospectively go back in and identify and tell the enterprise that, hey, you know, that was infected. And again, you know, some of these services, we expect everything to kind of move into a SIG market as time goes on, and they'll include all of the functionalities of your traditional cloud web security proxies, all protocols, file inspection plus AV, and even a lot of these vendors, you know, have sandboxing capabilities built in, where they'll automatically test malware, something that they don't know, and then auto-update their systems based on what they see with that. Last point here is the SD-WAN components can be fully virtualized. So there's nothing that says this all has to be hardware that's out there. The router itself can be a full virtualized environment. The only time we see the router can't be virtualized is if you need traditional WAN interfaces, things like T1 interfaces, serial interfaces, etc. Those don't come, you know, on standard server-based platforms. And also when you need voice applications running in those branch environments where you actually need the voice processing chips. That's hardware that has to run to do things like conferencing functions and other things. Those will still need to be built into the router. But otherwise, this could be built into anything with a whole bunch of Ethernet interfaces, and you'll have some layer of network software that can run all these virtual components, you know, on one platform. So you can have the router out there, the Nextgen firewall, the Nextgen IPS, you know, other things like wireless LAN controls. Really anything can run over these. And this can run over vendor routers, servers, or specialized hardware that's built for these virtualized functions. Okay? And it's 1 o'clock, and that's my presentation. Okay, Steve?
Well, yep. Well, thank you, Ken. That was very informative. It was you know, very interesting presentation. So you know, we are you know, kind of pushing our time here, but we'll just if you got a couple of minutes, we'll just hit a couple of questions at least. And so you know, given, you know, I'm just kind of curious, the state of the technology. You know, the government folks will talk about, you know, the technology readiness levels. So you know, where would you put us with the SD-WAN technology? I mean, are we still kind of in an R&D science project kind of stage, or you think it's mature enough where it's you know, where it's ready for prime time? So just kind of, you know, you've been dealing with it. So kind of what's kind of been your experience with it so far?
Yeah, so, and that's a pretty common question, you know, folks will ask that. And the reality is if you asked me that question, you know, a couple of years ago, I would have said, Steve, you know, let's wait and let's let that kind of bake out a little. But where it's at right now is it's gone through some cycles. This is fully deployable. The biggest caution that I have is on that direct internet access use case is if you're looking to just send certain applications out for that use case, that's the one that's still a lot of work in progress with there, depending on where the vendor's at. But if you're not in that use case, in particular, like a centralized model, fully deployable, lots of implementations, rolling out right now. So I would say this is now in the stage where it is mature.
Okay, thanks. So then I guess a follow-up is kind of looking at the security aspect. So, having, it seems like trying to utilize this technology, and organizations, kind of got to open their networks up to, the internet level access. So, how, are they opening themselves? What kind of risks or cybersecurity risks are they opening themselves up by using this technology? Is there, do you have a feel for how secure this is right now?
Yeah, absolutely. And general guidance is if all you're doing is that centralized model, that's no different than the way we've been running VPNs over the internet for years, and that's considered secure, as secure as it can get, running over that. So that is a well-defined, well-accepted kind of model there that folks are comfortable with. The biggest caution becomes, and I kind of highlighted this during the presentation, the biggest caution becomes the moment you say, I'm going to give direct internet access to those users. And if this is kind of just a guest access function, I'm pretty comfortable with that one as long as your segmentation is pretty good out there and solid and testable, and you can make sure that never the two, shall mix. I'm good with that. But the moment you shoot on over to those last two use cases where I'm letting everything out or I'm just letting a small subset of applications out, that's where I throw a big timeout. And, what I find, frankly, is a big difference between network folks and security folks. The network folks want to do it because it'll give a better user experience, and the security folks are horrified, and frankly, rightfully so, right? What did the government do, when they wanted to reduce their attack surface? The biggest thing they did many years ago is they reduced all their internet access points. And now you're talking about, kind of reversing a process like that where you're given direct internet access out to all these locations. And that has to be thoughtfully considered. And, you've got to look at having all the proper security controls in that environment if you are going to do that.
Okay, yeah. I know the government, they've been, NIST has come out with their, risk management framework, and so I think it probably depends on, each individual organization, kind of has to look at their particular use case and, depend on what kind of level of risk they're willing to accept, what level they're comfortable with, and you do have those various options that they can, kind of select to plug themselves into in order to to meet their requirements. So I think that's an interesting option there. So so we did have we stream live on YouTube and Facebook, and we did have a question come in off of YouTube, and I'd like to throw that question out to you. And I think this was back on I want to say like around slide 7, where you were talking about the SD-WAN controller and describing the the various functions that it performs. So the user was asking, what happens if the if there's a bug, some kind of a fault within the controller? What kind of problems is that going to cause in that situation?
Yeah, it's a good question. So generally, the controllers, first of all, are deployed in an HA standpoint. All the vendors will deploy them that way. So if a controller went down, they would have, the backup there. But the bug it's a very good question, and it really boils down to where is the bug in, right? If the bug is in, my provisioning and management piece, well, I might impact, bringing on a new site, until that gets worked out. But if the bug's in a routing, component there, it's very similar to if the bug was, in BGP or OSPF, on a router, and it depends on, the severity of that bug as to, what's going to happen to your traffic. That could be anything from, a minor black holing of, certain pieces of traffic to, catastrophic, routing failures. But it's the same concept there.
Okay. Well, thanks for answering that. Appreciate that. So we are past our regularly scheduled end time. So I will wrap things up. I want to thank you, Ken, for taking the time to do the presentation today. Like I said, it's a interesting technology, and I think it's probably something we're going to be seeing more of here in the future. And once again, thanks for informing our audience about the the current state there.
Yep, appreciate it. Thanks for the opportunity, Steve.
Okay, well, thanks for joining us, everybody, and I hope to see you next month. Like I said, we'll be talking about blockchain technology, and that'll be on the 19th of December. So everybody have a happy Thanksgiving, and we'll see you down the road. Thanks. Bye-bye.